In this video, we'll review the process of identifying outliers in a one-variable data set using the 1.5 times IQR criterion. The first thing we need to do is to identify the first and third quartiles, and while we're at it, we might as well get the entire 5-number summary. So if I look at the data set that's represented here at the upper left, I see that the minimum is 51, I see that the maximum is 100, and then I could either enter these into my calculator and get some one-variable statistics, or I could simply do some counting. So let's see how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 values in my set. That would mean that the median would lie between the 8th and the 9th. So 1, 2, 3, 4, 5, 6, 7, 9th and 10th. 8, 9, 10. So the median lies between 85 and 88, and that would put it at 86.5 if I split the difference between those two values. Now, because I have 9 elements in the set, I can or 18 elements, I can consider the bottom half to be a set of 9 and find its median, and that would be the 5th. So 1, 2, 3, 4, 5. That's the first quartile, so it's 81. And similarly on top, there are 9 values in the top half of the data. The 5th would be in the middle, and I'll just count down 5. 1, 2, 3, 4, 5. I find that the third quartile is 94. Now I need to, in order to identify outliers, first figure out what the interquartile range is. And the interquartile range is just the third quartile minus the first quartile. If I'm making a box plot, it's just the width of the box. And in our case, it's going to be 94 minus 81, which is 13. Next step is to multiply that value by 1.5. So 1.5 times the interquartile range, in our case, is 1.5 times 13, and that will be 19.5. And then finally, we need to use this value to get boundaries on the locations of outliers. And so we're going to take the third quartile plus 1.5 times the IQR, and for us that is 94 plus 19.5, which is going to be 110.5. And so anything in the set larger than 110.5 will be an outlier, and of course we don't have any. Then we're going to take the first quartile and subtract 1.5 times the IQR, and that's going to give us 81 minus the 19.5, and that is going to be 61.5. And we find that we do have a value less than 61.5, namely 51. So we have one outlier, and it's on the low end. If we then wanted to make a box plot that reflected the presence of that outlier, we would proceed in the usual fashion to locate, first of all, some scales, I guess, right? So here's 50, 60, 70, 80, and so on. Then we have a median of 86.5, which is about here. We have a first quartile of 81, which is maybe about there. We have a third quartile of 94, it's about there. That allows us to complete our box. And then we need to go out to the maximum of 100. And then because we've identified an outlier, we're only going to go to the left with the whisker to the lowest non-outlier value, which is 74. It's about there. And then we would separately identify the 51 with a little dot or asterisk or something of that sort. And that is a quick review of the 1.5 times IQR method for identifying outliers.